With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question says that in the given transformation, which of the following is most appropriate reagent, right? So we have tell the most appropriate reagent, right? So these are the reagents given in the options, right? So from this we have to tell that which of the following most appropriate reagent in this transformation, right? So let them drawing this transformation. This here you can see this is 6-membered ring, right? So this is our 6-membered ring, right? And here it is 6-membered ring, and here it is connected a OH group, right? So here it is connected a OH group, right? And here it is CH double bond CH, right? And here it is CO CH3, right? So this is the reactant, right? So we have to tell that what is the reagent, right? So that we get this product, right? So what should be the reagent so that we get this product, right? So this is our product, right? So here is OH part is unaffected, and here it is also CH part is also unaffected, right? And here this double bond part is also unaffected, right? Here, but this CO part is converted into CH2 group, right? So this CO part is converted into CH2 group, and here the CH3 is same, right? So here CH3 is same, right? So we have to tell that which reagent is most suitable, right? So in the option we have given, so we have given in the option, let I'm drawing this. So in the option we have given NH2 NH2OH, right? So NH2 NH2, right? In basic medium, right? NH2 NH2OH in basic medium, right? So this is actually a Wolff-Kishner reduction, right? So this is actually a Wolff-Kishner reagent, right? And in the option B it is given zinc amalgam, right? So Zn, right? So here it is Zn, zinc amalgam, right? In the presence of HCl, that means it is acidic condition, right? Here you can say that there is a basic condition, right? Here you can say that there is a basic condition, right? Because OH is given, right? So you can say that there is a basic condition, right? There is a basic condition, and here it is also you can say that there is a acid. So I can say that there is a acidic condition, right? So there is a acidic condition, right? And in the option C, it is given that in the option C it is given that sodium, right? In liquid ammonia, sodium in liquid ammonia, right? So actually this is Birch reagent, right? So Birch reagent which is used for the converting alkyne into alkene, right? So this is a Birch reagent. I can write here as this is Birch reagent, or you can say which is used in Birch reduction, right? So this is Birch reagent, right? And in option D it is given the sodium borohydride, right? Sodium borohydride, right? So it is kind of reducing agent, right? So it is kind of reducing agent, right? Reducing agent. This is agent, right? So here you can see this. The function of this reagent is to, but we have to convert this all the groups, right? So we have this group, right? So we have this group CO group, right? It is kind of ketone group, right? So is we have to convert this ketone group into CH2 group, right? So into CH2, right? So we know that the NaBH4, right? So the NaBH4 convert, I can write here as NaBH4. If I talk about option D, right? So the NaBH4 convert, right? So it converts C double bond O into COH, right? Right? So it is also H, right? So it converts just C double bond O into CHOH, right? So I can say that it is converting the ketone into alcohol, right? So it is converting into ketone into alcohol, but we are getting in the product as a alkane, that is we are getting as a CH2 group, right? So this should not be the answer, right? So this should not be the answer, right? And if I talk about the sodium in liquid ammonia, sodium in liquid ammonia, right? So this convert the alkene part, right? So this is, or you can say this is our alkene, right? I can write this clearly. So this is our alkene, not alkene, alkyne, right? C triple bond. I can say this is C triple bond CH, right? So this is our alkene. So when we do this, we are getting alkene product, right? So we are getting as alkene product, right? So here we are getting alkene, right? Here we are getting alkene. That means, but in the product we are getting CH2, right? So this should not be the answer, right? So here I can write as this is not the answer, right? And this is also not the answer, right? And now we are left with two options, right? So now we are left with the two options. So I can say that I can eliminate easily the option number D and option C, right? So I can eliminate these two options. Now we are left with these two options, right? So now we are left with these two options. So, and here you can say this is zinc in amalgam, right? So this is actually you can say that is a Clemson reduction, right? And this is Wolff-Kishner reduction, and this is Clemson reduction, right? And both these reductions convert the CO group into CH2 group, right? So both these reduction convert the CO group into CH2 group, right? But here you can see that the Clemson reduction, we use the acidic medium, right? So we are using the acidic medium. That means, and acidic medium, that means we are using an H positive ion. That means there is in the solution there will be an H positive ion, right? And here we can see this in our reactant part, right? So in the reactant part we have a nucleophilic part, right? So we have a nucleophilic, right? So there is a OH right here, and this is you can say this is our nucleophilic part, right? So this will attack the own proton, right? So I can say there will be a reaction as we use the acidic condition, right? So as we use the acidic condition, there is a possibility that the reaction will take place here, right? So to prevent this condition, right? So to prevent these groups, so we have to use the basic condition, right? So because these part are nucleophilic part, right? So these part are electron rich part, right? I can write here as these part these part are electron rich part, right? So we have to use such a reagent in which there is a basic condition, right? So we are left only with that answer, that we have used that option number A. That means we have to use this condition, because in this reagent we have given the basic condition, right? So option B also eliminate out, right? So the best reagent for this reagent is NS2, right? So I can write here as the best reagent will be NS2 in basic condition, right? So actually this is Wolff-Kishner reduction, right? Actually this is Wolff-Kishner reduction, right? So which convert just CO part, into CH2O group, right? So which convert just CO part into CH2 group, right? So now the correct answer of this question will be option A, right? So the correct answer will be option A, that is NS2 in basic condition, right? So this OH in this basic condition does not affect this OH and double bond, right? So it just simply convert the CO into CH2, right? And when we use Clemson reduction, so there is an acidic condition, right? So it may affect in this part, right? So we cannot use this, right? So the best appropriate answer is option A, that is NS2OH, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.